Hi, and welcome to Experience Week. We are excited to have you with us today. This presentation is titled Big Context, Humanizing Big Data from Connected Devices by Jason Mantell, Dania Rich-Spencer, and Lucas Loudon from MorePace. Before we jump into the content, I have some quick housekeeping items. First, feel free to share this event with your colleagues, as it's not too late to register. Second, let others know you're watching by tweeting at Qualtrics with hashtag ExperienceWeek. And finally, all content from today is available on demand, so enjoy. The time is now yours, Jason.
Thank you, Philip, and thank you everybody for listening to this webinar on Big Context presented by MorePace. For the next 20 to 25 minutes, my colleagues and I are going to share with you some of the most important learnings we've had from the past few years reaching into the big data space. And what we learned wasn't necessarily about the technology to use or the process to follow. Yeah, we faced the steep learning curve on these as well, and survived to benefit greatly from our adventures, both driving better business decisions from inside of our company, but also guiding our clients into the world of big data, improving their products and services with the most comprehensively informed decisions ever available. As a consumer behavior firm, MorePace is well positioned to embark on an adventure into big data. Working with data was natural for a firm that fielded market research for over 40 years, and there's a room full of statisticians here that know a thing or two about how to make data sing. But a hurdle for us was recognizing where injecting the human element was necessary, and when the data could step to the front and be the problem solver we all thought it would be. We weren't that different from any other company starting down the big data path. Gather it up, stick it in a machine, and out comes brilliance, right? Turns out big data investments brought forward as many new questions as answers and opened our eyes to what was missing, the human element, and specifically the contextual element of the analysis. So let me give you a quick introduction here to MorePace and our team. We're an analytics and modeling firm that specializes in consumer behavior. We call it humanizing data, and we've been doing it since the mid-1970s. Headquartered here in Detroit, we also have offices in LA, the United Kingdom, and Shanghai. From these select markets, you can probably guess we do a lot of work with automotive and transportation, which we do. But nearly half of our company is made up of healthcare, retail, and financial services business, and having such diversity allows us to learn from one another. My name is Jason Mantell, and I lead a team called Growth and Innovation, from which many of the leading initiatives in the company are born. I've been in the marketing and research business now for over 20 years and have never been more excited by the opportunities before us. We no longer need to create data to solve a business problem. We can start from the data that's available, and the results are so much richer from the breadth and depth of data at our disposal. Most of the presentation here today will be from my colleagues Dania and Lucas, who are strategists on our innovation team. Dania?
Thank you, Jason. I'm Dania Rich-Spencer, and I have over 20 years' experience with B2B and B2C research. I specialize in automotive, but I also have considerable experience in healthcare, financial services, retail, which allows me to share best practices and learnings with our clients across industries. Lucas?
Thanks, Dania. My name's Lucas Loudon, and I've been with MorePace for about 11 years now. And the lion's share of that time I spent doing automotive product clinics, and have since joined the growth and innovation team here at MorePace, and the last 2 years specifically focused on forward-looking data projects and positioning for the company. And now we'll share with us some context around the IoT.
Thank you, Lucas. Before we jump in and talk about humanizing big data and what exactly we mean by that, we wanted to take just a minute to share some interesting figures with you, as the projected IoT growth is quite impressive and honestly a little scary. As you can see, in just a couple of years, the number of connected devices is projected to be over 20 million. I've seen other estimates as high as 30 million. The monetary value is a staggering $3 trillion. And if you're interested, you can probably find a job in the data science and analytics area, as 2.7 million job openings are projected in 2020. Finally, on an IoT project basis, implementing such projects is not an easy task. Many projects fail to get off the ground, and few are claiming complete success just yet. Sometimes the lack of success is due to insufficient technical knowledge, inability to scale, or a lack of leadership support. Or sometimes it's simply because the business objectives and strategic vision was not well defined up front. While implementing an IoT analytics project may be a bit overwhelming due to its unfamiliarity, the positive impact to the business is just too great not to take on the challenge. It is particularly important to be open to the opportunities provided by the Internet of Things, given today's empowered consumer who's always on and is just one click away from defecting from your brand. We're seeing companies motivated by cost savings and revenue growth, which isn't surprising, but also a commitment to improving quality and safety, reducing time to market, and a desire to get closer to their customers. An MIT study revealed data-driven decision-making companies, on average, are 5% more productive and 6% more profitable. These outcomes can serve as a guiding light for companies considering implementing IoT analytics projects and initiatives. Some early adopters who are embracing the opportunities big data presents include manufacturing, transportation, logistics, and utilities. Intuitively, manufacturing is leveraging sensor data to increase productivity and to improve efficiency, as well as to detect failures or product variances. From a heavy truck industry perspective, streaming vehicle data from the engine and other component systems are used to flag potential breakdowns and system failures to minimize the amount of downtime. Location data is used for route optimization and asset utilization. And finally, utilities, thankfully, are using sensor data to flag potential failures that would lead to an outage or poor customer experience. Other verticals gaining momentum are automotive, where motivations reside in new revenue streams and autonomous vehicle production. Healthcare for designing custom care programs to improve population health, and retail is taking advantage of big data for very targeted marketing programs, and insurance is trying to better manage their risk pool. Based on a report published this year by the Internet of Things Institute and SAS, most companies are just beginning or have piloted just one or two IoT analytics projects. These companies have ventured out of their comfort zone, and with more experience, as the report shows, companies will reap a greater ROI. So it's important to be completely committed for the long haul when embarking on your IoT project journey. MorePace has stepped out of our comfort zone over the last several years and have embraced the opportunities big data presents to our clients, and we are definitely starting to feel the magic. With that, I'm going to hand it over to Lucas.
Thanks, Dania. So, as Dania mentioned, we've learned a lot in a relatively short time. Now, when we look ahead to what a data-driven decision-making culture looks like, we realize a paradigm shift is afoot. With so much passive data available, and still yet more coming, we readily find answers to a lot of the questions we used to have to ask: when, where, and how. This creates potentially the biggest shift in what we'll call the researcher's toolkit. Power from passive data can be harnessed using the New Age researcher's toolkit: disparate data streams, massive data depots, and machine learning and artificial intelligence. Even still, with all the power we get from data and tools, context still lacks. Now, context is provided by the human element in a couple of ways. First, bringing a perspective of business context to guide and train processes for automation. And we'll talk a little bit more about that here in a moment. I want to touch more on the second now, which is really just as important: filling the gap of why that lacks in most connected data. Think about these situations for a moment. So data says that a driver had a harsh braking event. Asking why considers the effects of the surrounding environment, like potentially being cut off in a highway merge lane, just as much as chalking it up to operator error. In another example, the shopper could go to the store 30 miles from home instead of one just 2 miles from home. Potentially that customer, maybe they were volunteering across town or heading to grandma's house, and it's really more than just an issue with that closer establishment to home. So this is really a key concept as it moves us from more of a transactional approach to more of a real-time interactional approach. This context gives more power to data than it is unguided and standalone. One thing that really hasn't changed much for us is the overall framework. This diagram and concepts on it should look pretty familiar to any of us. So we start by focusing on a narrow business problem and assess what we think is going on, the hypothesis. Now this is a key change as we move forward. Instead of identifying data to be collected at a later time, we immediately jump into the data we have and seek to understand the relationships of connected data, various enterprise data, and environmental data for application to the business issue. Once we understand the data streams, business rules get applied to transform raw, disparate data into useful business-specific key performance indicators and metrics. Often, this includes establishing benchmark targets, be they individual contributor-based, company-based, or industry-based. At this point, we already know the passive data we have and how we're going to transform it. Now we seek to provide the context, the why to our passive data by conducting contextual surveys based on data events, as well as layering supporting data feeds. And probably the biggest change allowed by technology, analysis and delivery, it's no longer spending hours wading through data searching for answers. By leveraging the New Age toolkit, the analysis is a forethought and has been established back in steps 2 and 3. The delivery is often by interactive dashboards with data available in near real time. So all these previous steps, we're working to develop and to support this end goal of insights and ultimately a call to action. The long view, it isn't simply just using descriptive statistics to support decision making, but ongoing inputs to the system that allow for predictive and ultimately prescriptive analytics. So what this does, this approach allows for exception-based management with reference to benchmarks and norms. So now, having talked about the process conceptually here for a bit, let's use this diagram to highlight the human elements throughout. There's really 3 phases of human interaction to highlight that enable successful outcomes. So the first we're going to want to talk about is organize. Really the most critical and time-consuming of the bunch, managed by the data analyst. So this stage includes activities like defining objectives and hypotheses, as well as the vision for success of the engagement. We're identifying data input needs from connected devices, enterprise data like equipment, financials, customer records, certainly many more that could be included in that, as well as data external to the business. Additionally, framing the data infrastructure and storage needs. How are we going to get that data in? How are we going to hold it? Building business rules and around transforming the data is an important step, as well as understanding the data limitations for contextual follow-up. What whys do we need to fill in to better understand our data? As well as lastly, and not least, applying benchmarks and norms that make sense for our use case. So the second point, contextualize, happens a little bit downstream. So as the data speaks to us, we want to seek out an explanation of why from the data subject. And we do that by contextual survey responses, as well as applying individually specific contextual data. And lastly, analyze. The data analysts, they take the nicely packaged data that we've worked so hard on and applies it for business use. And we do this by identifying action required based on data and exceptions, as well as using the support of data to affect organizational change. And now, many of the ideas we've discussed today, we've put to application already, And this case in particular was in partnership with a mid-sized transportation and logistics company. The idea was to take the data already available within their organization and make it useful and actionable for the business team. So a little bit more information about the fleet. So this fleet runs about 130 Class 8 tractors and trailers, all equipped with plug-in telematics device. The fleet is a mix of day cab and sleeper cab and a variety of for-hire scenarios. The fleet leader, while newer to the industry, he's open to the idea of applying technology and data to aid in their decision-making process, and really which is an otherwise more traditional gut feel and experience-driven industry. So Morepace made a site visit to consult the main players in the business, and we took away a detailed understanding of this specific fleet's business, and particularly the pain points that could be addressed with a data project, like excessive idle time, fuel efficiency, vehicles sitting longer than 34 hours, and miles traveled, all factors that impact the fleet's bottom line. So spurred on by this use case and other industry feedback, we've developed FleetPulse as the standard platform developed with industry best practices for ingesting the fleet's telematics data and distilling it to actionable outputs. And so we've talked about various human elements up to now, and so I want to highlight a couple of conceptual applications that we've experienced in this use case. So first, it takes extensive upfront work to build the stock deliverable. Even with built-in knowledge about commercial vehicles and fleet operations, significant time was spent by Morepace staff preparing a tool. And what we were doing with this tool was to establish an infrastructure to house and manage the data. Now, saying that out loud, it sounds easy, but there's really nothing simple about managing and linking a variety of disparate data sets for end use. Secondly, we want to understand the data in raw, moment-by-moment form and applying business rules to transform it into the useful business-specific KPIs and metrics. And that doesn't get into the programming of those transformations. Lastly, the data visualization, that's a hot topic these days and one that definitely should not be overlooked. Visualizing the data and putting that vision into an interactive, deployable interface was another big effort. So in another example, in the commercial fleet industry, there's so much nuance and specifics that there's not many businesses that operate exactly as their competitors do. So ultimately, this requires more of a custom approach. So what we did, working with the fleet leader, we worked to understand their pain points in day-to-day operations, and that helped us to define norms as well as rules or performance exceptions, if we want to call them that. Layering context where those exceptions or faults occur, asking the drivers why certain exception events occur, gives a clearer picture to the fleet leader. Pulling in the performance data, context, and applying norms allows us to provide the fleet leader with the action needed report you see here. Where the vehicle is, what exception was triggered, and how that performance compares to the identified norm. Decision-making with this level of detail, it allows the fleet leader to decide whether to take action or not, and what action is necessary. Now, the long view of this approach allows for a feedback mechanism that enables prescriptive analytics. The fleet leader tells the system if and what action was taken, and over time the system learns tendencies and therefore can recommend actions to be taken in the future. So I want to talk a little bit about a specific case of FleetPulse supporting the fleet leader now. So we had developed a report around idle time that provided the fleet leader descriptive analytics, what has happened. And we compared each driver against the fleet's 75th percentile performance benchmark. The fleet leader opened the analysis to focus on which drivers were underperforming to the benchmark, and specifically the day cab drivers who spend too much time idling. For a little bit of context around that idea, the sleeper cab drivers were omitted because of a reasonable expectation of that vehicle idling to maintain the cab environment while the driver is on his sleeping berth or his overnight break. So from this analysis, we were able to identify a handful of day cab drivers who were idling more than would be expected, and the fleet leader was able to address the underperformance and coach the driver on techniques to limit their idle time. So the nice thing with an approach like we have here with Fleet Pulse, the advantage is we have a lot of unknowns. There's predictability to an extent. And now Dana is going to tell us about another example where there are far less knowns. And in that case, understanding the situation is a bit of a fishing expedition.
Thanks, Lucas. Connected devices, in this case, streaming vehicle telematics data, is redefining how we study human behavior. We no longer have to rely on people's memory, which we know is not always 100% accurate. We can leverage real-world driving data collected from a vehicle, such as location, speed, harsh braking, rapid acceleration, even seatbelt usage, and diagnostic codes, and we can use this information as a springboard to conversation with the driver. This engagement with the driver lends contextual understanding to the telematics data in near real time. We no longer have to rely on after-the-fact, self-reported measures related to vehicle usage and ownership experiences. As mentioned earlier, automotive is embracing the opportunities presented by connected devices and leveraging onboard diagnostic data for early detection of equipment failure, unforeseen quality issues, and unintended safety risks. Manufacturers are motivated to leverage big data due to the competitive pressure from both within and outside the industry. Just think about Google and self-driving vehicles. Autonomous vehicle technology, new powertrains, and consumer demand for personalization have contributed to rising vehicle complexity. I heard on the radio just a couple of days ago that a university study identified a vehicle that had 50 infotainment buttons. With increasing complexity comes a greater chance for unforeseen quality issues and subsequent recalls, which of course are quite expensive and should be avoided. The challenge for automotive OEMs is that it's expensive and time-consuming to gather large samples of representative real-world driving data. To address some of these challenges, Morepace partnered with the manufacturer on an innovative IoT project designed to identify unforeseen quality issues on a brand new model. This is an excellent example of inviting customers into the product development cycle as a demonstration of the commitment to being truly customer-centric. We recruited almost 100 early buyers to install telematic devices into their vehicle and to join an insights community. The community approach allowed us to engage with these early buyers over an extended period of time via surveys and forums, which was considerably less expensive than a series of ad hoc research projects. You may be thinking that it would be difficult and time-consuming to get people to participate in a project that requires such a large commitment. But actually, the recruit was surprisingly easy. These folks wanted to engage with the OEM and felt honored that they were invited to share their experiences with their new vehicle. These customers enjoyed being treated as a company insider and sincerely wanted to help make future vehicles better. As a result, we saw very positive comments in customer forums about the specific R&D initiative. Prompted by fault codes and patterns in the telematics data, Morepace, in conjunction with our client, designed research activities designed to obtain contextual understanding of driving behavior and vehicle usage. Having real-world customer driving data geographically dispersed gave the engineers a heads-up to potential quality issues and the extent of the problem. This helped to inform the OEM if the issue could be addressed remotely with a software update or if more elaborate measures needed to be put into place. While the focus of this initiative wasn't to gather customer feedback on brand or dealership experiences, creating the insight community where members were committed to engaging over a period of time and are essentially waiting in the wings to provide feedback turned out to be a very cost-efficient and relationship-building opportunity for multiple stakeholders in the organization. With that, I will pass it back to Jason to wrap things up.
Thank you, Dania and Lucas. So for all the talk around Internet of Things and big data, the data alone doesn't speak to us or solve all of our business problems. Our topic here today is a reminder of the human element that is so critical to solving our business issues with the data available to us. We still need people to strategize, to create theories around those issues to be solved. What might the data solve for us? We need people to organize because data starts messy and unclear, and getting it to a place of usefulness is extremely important. Poorly structured data creates garbage in, garbage out. We need people to adjust along the way, as the typical path to an answer will take several twists and turns, and then ultimately it's about humans to analyze. The results and actions arise from the personal interpretation of those data outputs. The beginning of any data-driven initiative involves humans who assess the situation, identify the problem that will be solved by using the data available. In research, we use the term hypothesis on every study. Without an objective in mind, there is no direction. Machine learning is iterative in itself, but also iterative is the human interaction necessary to learn and improve. There is no machine that will solve a business problem for us without someone guiding it. Machines need positive and negative feedback to be successful, just like people. Human perspective is invaluable as an input to the data. Often overlooked, human inputs are not only guidance to the system, but also the contextual data overlay. That data generated through consumer opinion and observation. The context around the data is absolutely necessary to draw conclusions. Without the human input, sharing perspective, identifying nuance, recognizing exception, the results lack the why of an occurrence that exists in our data. Or as a simple example, why did the product behave the way that it did? Was it the fault of the product, or was there some interference? Change comes through people. Performance improvement does not happen from a report. It happens from people applying the learnings. And leaders create the actionable outcomes from any big data effort, applying their experience and knowledge, those subjective inputs that a machine can simply not process. The one thing we'd like you to take away from this presentation is the idea that big data may be the inevitable future of business that lies ahead of us all. Big data will tell us what, when, where, and perhaps even how a product performs or a situation unfolds. But in the absence of big context, the answers to why something happened in that data, the application of any learning remains incomplete. Human involvement remains irreplaceable. This concludes our presentation. If you have any questions, feel free to reach out to us, and we'd be happy to learn together on any ideas that you may have. Philip, I'd like to pass it back to you.
Hey, thanks to all of you for joining in today, and a big thanks to the MorePace team. Just feel free to check out the rest of the great content.